Right. Let's go through. You can tell me what you do and don't know. I think for one question, a couple of you just forgot to follow on from the fact that 4b is following on from 4a and uses the same information. But let's go through these. You can write down your solutions, so something to revise from next time. I've got this. This is quite often the standard type of question. I'm told that x is natural log of 3 and y is natural log of 5, and I've got put in terms of x and y. So I think about the rules of logarithms. So if it's a division, I know that it's going to be the natural log of 5 minus the natural log of 3. Okay, which, if we'll get this the right way round, one of you, okay, is y minus x, not x minus y.
How is it? Oh, yeah.
Because x is the natural log of 3 and y is the natural log of 5. Natural log of 45. So a lot of you
Wait, there's a way.
were...
That was the answer?
That's it? Yeah. Did you? What?
Look how sad she looks.
No, x minus y is the answer, or y minus x is the answer. Yeah, it's got to be in terms of x and y. Now this one, again, we know that x is what, the natural log of 3, and y is the natural log of 5. So I'm looking for that in 45. So I know, okay, well, some people put 3 times 15. Better is 9 times 5. Because then that's the natural, so if I put that in bracket, then that's the natural log of 3 squared times 5. Now I'm getting what I want. If it's a multiply, that changes to the natural log of 3 squared plus the natural log of 5. So that's the y. Natural log of 3 squared is the same thing as 2 times the natural log of 3, because the power goes in front, which is 2x's. So I end up with 2x plus y.
So what this question was asking was just for both of them, put it in the form of x and y.
Yes.
Okay.
Yeah, definitely.
I skipped these, so I thought they were too hard.
Second part is quite tricky. First part's really easy. We just need to know that 3 to the power of 3 is 27 and 3 to the power of 4 is 81. Therefore, m equals 3 and n equals 4. You have to actually write that m is 3 and n is 4. Okay, not the whole thing. Right? And it does say for part B, hence or otherwise. So what we were looking for is the fact that, well, let's change the 27 to 3 to the power of 3 to the power of 2x plus 2 is equal to 3 to the power of 4 2x minus 3, which becomes 3 to the power of 3 times 2x plus 2 equals 3 to the power of 4 times 2x minus 3. Now, this is the kind of step that maybe you're not used to taking yet. Well, if it's 3 to the power of that equals 3 to the power of that, well, the powers must be the same because the base is the same. So I can, without doing any logarithms at all, just write 3 times 2x plus 2 is equal to 4 times 2x minus 3. So that's kind of the big step you have to be able to take. Alright? It's a logical process, which we still have to solve, of course. So we've got 6x plus 6 is equal to 8x minus 12. Subtract 6x, which means 6 is 2x minus 12.
Wait, how did you...
Go on. Add the 12 gives me 18 is 2x, which means x equals 9. Which bit are you struggling with?
They're both to the base of 3, right?
Yeah.
So like if both of your things were like 4/8 equals 6/8, they're both over 8, so it doesn't really matter.
Well, more like if you have 4/8 equals x over 8,
Because it's 3 to the power of 4.
then I know
Because
4 has to be x.
Okay, I get that.
Same thing. If this is 3 to the power of x equals 3 to the power of y, x and y have to be equal.
Okay.
Because you can't do 3 to the power of different numbers and get equal things.
Okay.
So I can just make the statement that x has to be the same as y. Now, at the start, they're at different bases. So I can't say that that's equal to that. But by using part A here, I can convert 27 and 81 into a power of 3. And that's what I need. I need that same base. So once I've got the same base, I can just say, well, now the powers must be the same. Must be equal. All right. But a tricky one, I don't think many people got much there. But does it make sense now? Would you be able to use that now?
Yeah.
Yeah? Okay, this one. I think on the whole this one was more of a success. So we've got to subtract, so we end up doing log to the base 3 of 54 over 6. So that's log to the base 3 of 54 divided by 6 is 9. Which is log to the base 3 of 3 squared, which is 2 log to the base 3 of 3. Log to the base 3 of 3 is 1, so the answer is 2. Just that. Yeah? Right, this is where people got confused, especially with part B. So I'm told that log to the base 2 of k is equal to 7, and log to the base 2 of f is equal to 8. Find log to the base 2 of f cubed. So first step is to say, well, that is 3 times log to the base 2 of f. Oh, so log to the base 2 of f is equal to 8, so I've got 3 times 8, which makes 24.
Is
Look
that
at me
That's all
like
that was?
That's all that was.
What?
I think I'm taking this as another it's your first test, and I
Yeah,
don't
no.
really you
Got
don't
very
know what
mature
they're
answers.
asking
Yeah,
for.
exactly.
Well, you do. The wording, getting used to.
Well, I guess what we have to take from this as well is you need more practice, don't you? You need to at home have sat down and done more of this from the textbook. You know, I maybe could have given another lesson on it as well and given you more guidance, but we've both got our part to play in it, haven't we? You've got to do more. Say it again.
How come it's not a to the power of 3?
Because that's not what laws of logarithms are, is it? You can't just do that. So if I've got log...
It goes in front.
Exactly, yeah, we're using the laws of logarithms. I can't just cube the value, and it's not how it works.
I learned so much.
Pardon? No, they didn't. There's a part B.
I was like, that's a big number for some reason.
We are told, by the way, for part B, I know it's on this different page, but I'm told log to the base 2 of k is 7. So that's for part B. Log to the base 2 of k is 7. Okay? So we've got log to the base 2 of 8k. So that's a multiply. So we've got log to the base 2 of 8 plus log to the base 2 of k. So log to the base 2 of k is 7. So we've got that straight away. We just need to know what log to the base 2 of 8 is. Well, log to the base 2 of 8 is log to the base 2 of, we want a power of 2, so it's 2 cubed, which is 3 times log to the base 2 of 2. log to the base 2 of 2 is 1, so it's 3 plus 7 makes 10. Okay?
Mr. Potts.
Yes.
I wrote so much and it took me so long, not so
Same.
long, but
I
I wrote
did
so
that.
much to figure that out.
I would say,
3 steps.
if ever you're writing too much, it's 3 marks, you know.
Like
3
I
marks,
understood
3
what I
steps.
was doing, but
Yeah.
like I just wrote so much.
I was
Yeah.
really mad at myself. I
was really
multiplied it
tired.
rather than added it.
Yeah.
Wait, is this a joke?
You need to know my flaws.
I got all the right
Not what I wrote. I
It's
did.
more complicated
I got the first.
than. Well, that's a good point. At least you're saying, what was I doing? Would you know what I'm talking about, yeah?
I understand.
You understand. Okay, so next time you'll know. This bit then. Alright, so we've got to find it in the form natural log of k. So hopefully you went straight for, oh, there's something in between, so we've got to do natural log of 3 squared plus the natural log of 5. So then that's the natural log of 3 squared times 5. So that's the natural log of 9 times 5. So it's the natural log of 45.
Oh wait, hold on. You got that?
That's it.
I don't know. Sometimes I look at what I did and I'm like, oh,
I'm glad you said that, because sometimes I look at what you guys wrote and think, where is that coming from?
You know, if we worked in pairs, it'd be great because like the things she got right, I got wrong. Things I got right, she got wrong.
yeah.
So what does that tell you? Need to work better together? Or does that make sense to you so far?
Yeah. I thought it was LM30. Actually, I don't even think that's natural
Oh, I did see someone, I think, write 3 squared was 6. Is that you? I think it was, yeah. 'Cause 6 times 5 is 30. So that, how can
The
you...
only reason why I got the wrong. I hate
Yeah.
my life. It's okay.
But that's the trouble.
Because I was like, just like, okay, yeah, 3, 2 times, go.
Yeah. You've just got to take that extra moment to breathe and, you know.
I made
your
3
brain.
silly mistakes and I could have gotten a 5.
Now, so let's talk about this one. I think a number of people kind of knew what they were doing.
I didn't like this question.
Find a common ratio. So first of all, we have to turn it
I don't even
into
understand what that even means.
27 natural log of x. The next term is 9 natural log of x. The next term is 3 natural log of x. By converting it like that. So all we have to do really is say, how do you find a common ratio? Well, you do this term divided by this term, or this. So you do it that way. So if I do 3 natural log of x divided by the 9 natural log of x, I get 3 over 9, which is a third.
Close.
Okay, I did divide. I
wrote it. That's what I said.
didn't know what I was like.
Right, so just a couple of notes here. The answer is a third.
Is that the same as 5 by 3?
Right, see, I know people. Remember, a common ratio is I want to know what do we need to multiply by each time
That's not fair.
to get. So we remember we talked about sequences. You don't divide, we multiply by a common ratio. Because if I was going to use the formula for the sequence, R is multiply.
I saw a third.
I saw, no, I wrote a third and then I saw the exponents and I was like, you gotta get the third to be on top.
I got the third, then I was like, oh no, it's 3, and I divided it the other way around.
Yeah. A couple of people did that actually.
I said 3 squared is 6.
Alright,
These questions, that's
I said divide 3. Good.
next one. When I marked this, I just went straight to the answer and I was like, oh no. But then when I went through it, actually a lot of people put some good stuff down for this question.
nothing.
Oh yeah, I got
So this one, it's quite good. You've got an arithmetic sequence. The first term is natural log of w. The common difference is that. So I know, everyone, un is u1 plus n minus 1 lots of d. So you can have marks for saying, first off, un is the natural log of w plus n minus 1 lots of the natural log of 5. Now we've got the 15th term is that, so we would then write, so we've got u15 is 5 natural log of 25, so we are then writing 5 natural log of 25 equals the natural log of w plus 14 natural log of 5. So there's kind of marks at each stage. Hopefully I've given all that you deserve. Right? Yeah, there's quite a lot of marks given just for the writing each stage. So you kind of get a mark for doing that, and another mark for writing it equals that value.
What did I do wrong?
So what we do then is there are a couple of different routes. But what we need to do is get natural log of w. I want to find w, so that's what I want to make the subject. So I'm going to subtract this, so I've got 5 natural log of 25 minus 14 natural log of 5 equals the natural log of w. So that then tells me, right, I've got to be able to combine those somehow to get one natural log, so this needs to be simplified. So there's a couple of ways to do it. Some of you converted this to the natural log of 5. I quite like, it's not the way I did it, and then I saw you do it. I was like, yeah, I quite like that, that's better. So this someone put as, that's 5 squared, right? Which meant the 2 comes in, so it becomes 10 natural log of 5. Does that, I've taken a shortcut there to save space. Is everyone okay with that? Do you want me to write it out in full? Yeah? Okay. So what I've got is that becomes 5 natural log of 5 squared. Then the 2 comes and multiplies in front, so it becomes 2 times 5 times the natural log of 5, which is 10 natural log of 5. Okay? And then this one just comes straight down. It's still 14 natural log of 5. Alright? All of that still equals the natural log of w.
Wait. Oh, this is giving me a headache.
Yeah? Okay with that a moment? So then I've got 10 natural logs of 5 minus 14 natural logs of 5. I end up with minus 4 natural logs of 5. Which if I convert it back, I end up with the natural log of 5 to the power of minus 4. Therefore, w equals 5 to the minus 4. Or 0.0005. It's not right, is it? No, it's not 0. 1 over 5 to the power of 4. Yeah? So there was lots of marks given. There was kind of like a mark for writing that. There was a mark for doing a subtraction. There was a mark for converting into the same. Okay. I think there was actually a mark for doing this bit without that bit, doing equals, and just a separate mark just for saying that equals that. So kind of that would be 2 marks. So there was kind of, you could earn those marks all the way through. Alright? And then there was only minimal couple of marks just for the end point, which is quite nice, I thought. You could earn a lot of marks. Does that make sense to everyone? Do you think you could do that next time? Right. This one, I was disappointed with this one actually. I thought you'd get this one.
I forgot Sigma.
Yeah.
Well,
I did so much again and then I lost track.
you're going to kick yourself.
Yeah.
Expand, so that means R is going to be 4, 5, 6, 7. So this will be 2 to the power of R is 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, 2 to the power of 7. The sigma means add, so not that one. Add.
Oh, yeah, right.
Yeah.
And
that's
it's-
all.
You could say 2 to the power of 4 is 16 plus 32 plus 64 plus 120. Either way, I'd accepted either of those.
But it's not like if you add all the terms together, right? Like you,
Well, that's what it would be asking you to do, but it says expand it as the sum of 4 terms. It means just write down the 4 terms. That's all it means. It doesn't want you to actually add them together. So if you, for instance, didn't write the 4 but added them together, I couldn't give you the mark. Right. Now, this one, the next part of the question, I did think, alright, I should have gone through one of these with you.
What
And I
it says
did.
explain, can't you just write it? Like, because I said.
Yeah, you just have to write the right thing. Let's go through the part I. I definitely, this is something that I kind of hoped you might have come across in your textbook. Obviously you didn't. Right, basically it's this. You start, I think we talked about it briefly. You have to start at the 4th term and go all the way up to the 30th term. Alright? Now there are 2 ways to do this. You can either work out the sum of 30 terms and then subtract the sum of 3 terms. Does that make sense? Because I only want the sum from 4 to 30.
oh,
So if I do 1 to 30, I've got too many, which is what a lot of you did. You just did 1 to 30. So I would have to subtract the first 1, 2, 3 terms. Or I think of it as a different way. Instead of doing 4 to 30, I think of it as the sum of 27 terms, where U1 is 2 to the power of 4 rather than 2 to the power of 1. Does that make sense? No?
No.
Okay, so if I write U1, U2, U3, U4, U5, all the way up to U30, right? What's U1? It's 2 to the power of 1, which is 2, 4, 8, 16, 32,
Oh, so you're just making
128. All the way up
the
to
one,
2 to the power of 30. Okay? Now, if I wanted to know only from 4 to 30, I could do this, but I only want that, so I'd have to subtract those ones. Alright? So the way I could do that then would be, well, what's the sum of a sequence? So it's S30 is equal to U1 times, what was it, R to the power of n minus 1 over R minus 1. So what is R in this case? Times 2. Alright? There was a mark for that, by the way, so if I've not given it to you, if you've written anywhere R equals 2, and I haven't given a mark, give yourself a mark.
I've put it into the equation.
Okay. Well, if I'll check,
Yeah.
because maybe I didn't spot it and I'm going. So you should have a mark for just realising R is 2. Right, so if I did that then, I'd have S30 is U1, so 2 times 2 to the power of 30 minus 1 all over 2 minus 1. But I would have to subtract, well in this case it's just 2 plus 4 plus 8 is 14, yeah? Which would be the sum of the first 3 terms. Does that make sense? Yes, no?
yeah.
Feedback, good. Alright, so I can't do it just up to 30 on its own. I have to subtract the first 3 to get what I need. Right. That's fine. Are you ready for the alternative method? Or are you still writing?
Just show us the alternative.
I'm sure. The alternative method is, instead of having to do the subtract those 3, is I change it and I say U1 is now 16,
Oh, I like that better.
and instead of going up to U30, I'm actually only going up to U27.
I like that.
So now I'm doing the sum of 27 terms. The first term is 16. I'm doing, the common ratio is still 2, but I'm doing 2 to the power of 27 this time, minus 1, all over 2 minus 1. And then there's no subtraction needed. So you've got either or. And this is where I was sat there going, yeah, we didn't do one of those together. They will be in the book, but you obviously didn't get that far, or my fault for that one, I would say. Say that again? Sorry, no. Because it was in the book and you could have done it. Alright. Say that again?
The next question.
The next question.
Wait, that's it.
Explain why. But didn't you get this?
No.
Oh. The answer for this one is simply because the ratio is more than 1.
Mr. Potts! Wait, did I write this correctly?
I wrote that.
Wait, I need to look at a sign, make sure I wrote my sign correctly, because I spent a good 2 minutes trying to figure out which way my sign was.
So basically, you can only sum to infinity, right? So the sum to infinity is when r is less than 1. Is the only time you can do it, isn't it? Alright? Or should we say the modulus of r? So we have to specify somewhere. I mean, you would write a bit more than I've written there. You probably wouldn't get away with just writing that. But that's basically the gist that they're looking for, right? So we would be looking for, it's not a convergent series as r is greater than 1, for instance. So you can't sum to infinity. So they're looking for that, saying it's not convergent, or it's divergent, or it continues to get bigger, therefore there's no limit, or whatever language you want to use, as long as, you know. So we could say there's a no limit as it's divergent. So in this kind of language is the kind of stuff when you start doing your IA, I would like to start seeing the proper language involved. But for this, only 1 mark. You kind of get it if you. I think a couple of you got marks for it, didn't you?
1.
Well, that's all it is.
For writing all this.
Yeah.
I said it, but I just didn't say. I just needed to. I said and r is less than 1, but I said r has. I have to say r has to be
Yes.
less than 1 because I made it sound like it already is less than 1.
Oh, we have
wasn't.
Yes. Is that yours that said r is less than 1, but it's not in this question?
Yeah, like I was saying it. Like it. I meant to say it has to be.
Yeah. Right. Okay. The final one. This is the hard one. Although no more difficult than any of the others, to be honest. But it's kind of getting there. So basically, we want to express GV in the form that. So I'm going to look at GV first. So GV is the natural log of 7v to the power of 4. First thing I'm going to do is split that, right? But I'm looking at the natural log of v squared. So I've got the natural log of 7 times v4. So that will be the natural log of 7 plus the natural log of v to the power of 4. You okay with that? So again, well, same reason you knew all the others. You split the multiplying, yeah? Now, this is where, actually, I had to rewrite this question. I made it slightly more difficult than the original. But same principle. I want this bit, so I've got the natural log of a, that's the natural log of 7-bit done. So I just need to make this into k times the function of v. Now the function of v is natural log of v squared, so I need to figure out what that is. So we've got the natural log of 7 plus, and this would be the natural log of v squared squared.
So it would be 2.
So natural log of 7 plus 2 natural log of v squared, which is then natural log of 7 plus 2 function of v.
Why would you just move the 4 over to the front?
Because fv is the natural log of v squared. If I'd have brought the 4, I wouldn't have had the function of v, I'd have had something else. So that's where you don't bring the whole power, you have to split the power. So it's kind of an added little step in there. So that's a real differentiation between someone that kind of knows what they're doing and follows the brickwork, the steps, and someone that really understands what they're doing. To be able to split the power and take what you actually need there. Okay? That was it, I think. So we'll test that, isn't it? Any further questions on it? Anyone think I owe them any marks? Happy to give them if I've made a mistake.
I put the comment. I wrote it.
Okay, so I am recording. So
Because I'm on it.
right, should we? If we're going to expand x minus 2 to the power of 4, then who wants to talk me through it? 4 0.
X to the power 4.
Yeah.
4 1.
Plus 4 1. X to the power of 3 times minus 2 plus 4
X squared times
x minus 2 and then plus 4. So we haven't actually done one yet. That's why I set this one where we then combine it and all simplify the whole thing. Do you know the values for these? So it's obviously 1 x power 4 plus 4, so that's 4, and this is minus 2, so it's be minus 8 x power 3 plus, what's that? 6 is it? Okay. So 6 times minus 2 squared is 4, so that's 24x squared plus, that's 4 I take it, that's 1, so then 4 minus 2 cubed is 8, so minus 8, so minus 8 times 4 is minus 32x, and then finally we've got minus 2 to the power of 4 is
4, 16. Wait.
16, yeah. So plus 16 at the end. So then it's just x to the power of 4 minus 8x cubed plus 24x squared minus 32x plus 16. So that's my expansion.
Where's that minus 8 go?
Here.
No, up there. It's just floating in the air.
Is that the final answer?
What minus 8 floating around?
Yeah, up there.
Oh, that's the minus 2 cubed.
What about that 4 that's floating up there?
That's the value of 4 over 3. 6 is 4 over 2. Yeah.
So then don't you need to simplify it?
How?
Okay.
There's no more simplifying. I think the simplifying was the knowing that minus 2 squared is 4 times the 6 makes the 24 and so on. Okay, so we've talked about this type of question before that could be very hard or very simple. So it says find the term in x cubed in 3x plus 4 x minus 2 to the power of 4. So who did this? Who knows how to do it? Go on.
So what I did Is I took the 3x plus 4 and then like separated it per se, and like you just do the binomial expansion with the x minus 2 to the power of 4.
Yeah.
And then you find the third term. You like, do your expansion and all that stuff up to.
You know, we've already done the expansion, yeah?
Yeah.
In part A.
So the video that I looked at, because it's x3.
Yeah.
You do the 4 1 and then the 4 2 because the 4 0 is just gonna get you to.
I think you're overcomplicating it. Have your video told you?
It was a bit confusing.
Did anyone else have a? Say it again, sorry. Okay, so I need, in my expansion, I want the x cubed. In this expansion, I need the x cubed. Now, what you're supposed to realise is that you've already done this bit. X minus 2 to the power of 4. That's here. Alright? To do the expansion, this expansion, all of these terms would just be multiplied by 3x plus 4. Alright? So it would be this time, this one times 3x plus 4, this one times 3x plus, and so on. Now, which one is going to end up resulting in an x cubed? Well, it's only one x, so it's going to be the one with x squared in it. So I just take the 24x squared and I multiply it by 3x plus 4. Because then that will give me 3x times 24x squared. Well, it gives me the x cubed, and 3 times 24 is 72, alright? And then so that's that bit, and then the 4 times it becomes plus alright? Now, what do you notice? Why did I what?
Take the 24.
Take the 24.
Where to make x cubed.
Because that gives me my x cubed bit. Now, what do you notice though? That we get the x cubed bit, but we also, because of the plus 4, get an x squared bit. So do you think there's going to be any other x cubed bit in this expansion? Where from?
Oh, that's what it was called.
Because if I multiply the x squared and get an x cubed, great, but I also get another x squared bit. If I'm going to get another x cubed, I'm probably going to get it from the x cubed. So I've also got to do the 3x plus 4 multiplied by the minus 8x cubed. Because that then gives me minus 24x to the power of 4, which is fine, I don't need that bit. But it does give me the minus 32x cubed bit. Sorry, not x to the power of 4, x cubed. Alright? So in this expansion, I actually end up with this part and this part will eventually go together and simplify and become an x cubed term in their own right, and it will become 72x minus 32x cubed will be how many x cubed? 40. So in this expansion, the x cubed term will be 40x cubed. So it's kind of having the other one we worked on was simple because we only need to look at one term. But in this one, when you do that expansion and multiply it, we end up making other terms as well that need to come together. Does that make sense?
Yeah.
Or is it still a bit kind of grey area, a bit hazy? Bless you. Yeah? No? Is there anyone that's grey with this at all? Not quite sure the way I've... Because what I've... For me, as the teacher in my head, I've kind of done the 24x bit squared first, put it there, and then I've gone left but put the answer to the right, and I know that can sometimes confuse people. So you're happy. Because what I maybe would have done is say, what's the initial expansion again? So it's x to the power of 4. How many x? So the original part A. Can you just tell me that again for me? The original expansion, x to the power of 4
minus
8x cubed plus 24x squared minus 32x plus 16.
Okay, so what I should have done was maybe take this one, expand that one, and then take that one, and then expand, and I've got it the other way. So when I expanded this one first, what did I have again? So when I've multiplied that by 3x plus 4, what did I end up with?
72x cubed plus 96.
Plus, sorry, what?
96x.
No, that was when I put them together. What was it? This one, when I multiplied by 3x plus the first line I did, what did I end up with? 72x squared plus...
96x squared.
Oh, is that what you were saying? Sorry. X squared. And then when I did this one the second time round, this would have become, I also multiplied by 3x plus 4. That one became
24
minus 24x to the power of 4.
minus 32x power of 3.
Okay. So that's what it would start looking like. I've not done these two bits.
It's 32x.
Alright. So now I'm collecting my like terms and I'm taking my two x cubed bits together, and that becomes 40x cubed. So just hopefully if I've done that better. Okay?